Okay, let's get started. Finally, the last session of the day. Thank you so much for coming to my session to finish what was hopefully a good first day for you here at NDC. So, welcome to this session about Azure Container Apps and Dapr. My name is Jakob Ehn. I'm coming all the way from Stockholm, Sweden, working for a company called Active Solution. It's a consultancy company. We're working a lot with Azure, obviously. A lot of cloud-native things, a lot of containers and so on, helping customers move to Azure and so on. I'm an Azure MVP. I've also worked a lot around the DevOps, ALM area. Wrote some books, which was a fun experience. I didn't make a lot of money of it. And if you write a book, never put a year in the title. That is my first recommendation for you, because then people think it's goes out of date very, very fast. So that was a lesson learned, but it was fun anyway. So, okay, so this talk will not be about microservices per se. There's lots of talks about microservices and how they work, if you should choose to use that architecture or not. But I do want to start of talking a little bit about the fact that if you go the microservices route, splitting your system apart in smaller services, maybe using different tech stacks because they fit that particular service. If you do that, containers is a really good choice for you of building, packaging, and deploying your microservices. Because once you put these things in a container, it doesn't really matter what's inside them. It doesn't matter if you do .NET or Java or Python. Container is a very nice standard, and once you have it in a container image, you can really deploy it anywhere as long as you have a container orchestrator somewhere. So it's a really good fit. And if you're using Azure, there's a lot of options for running containers, all the way from the simplest, which is probably Azure Container Instances, all the way to the full-fledged Kubernetes service, AKS. But today we're going to talk about Azure Container Apps. And so if you're looking at, if you want to run multi-container applications, so your system consists of multiple containers, what do you need when you deploy these things in a real environment? Well, or actually when you're also developing the systems. Well, to start with, you need a way to do service discovery. So if you have multiple services, you need to have a way to have service A being able to find service B, and obviously also make service invocations on them. And in a multi-service environment, probably running on multiple servers somewhere, this can be a tricky problem. You can't be sure where a particular service instance is located. Also, there might be multiple instances if you scale out. So you need some easy way to make this just work, and also just work depending on where you are, if you're running it locally or if you're running it in the cloud. You also want to have a way to do deployments without causing a lot of downtime, which is, one of the obvious benefits of doing microservices is to be able to deploy, individual services without deploying the whole system. So you want to be able to deploy fast many times. That also means that you don't want to have downtime. So you need to make sure that, the container orchestrator of your choice is able to actually spin up your new version and route traffic to it without causing any downtime. Also being able to scale your services based on different metrics. Could be things like the number of requests coming in, CPU load, maybe the number of messages on a queue. Those kind of things is what you want to be able to scale your services up and down. Also things like monitoring, tracing, those kind of things, quickly becomes a lot harder when you do microservices compared to a monolith where you have everything, pretty much in one place. And also it would be nice if you don't really have to, care about the infrastructure, right? No infrastructure to manage. That's obviously not a requirement, but it's really, really nice compared to having, a lot of virtual machines that you need to, patch and manage and upgrade and so on. And also to really be able to use the cloud for what it is, being able to pay for the resources, that you actually use instead of pre-provisioning a lot of the resources. Ideally, you just want to pay for the amount of resources that you use. So typically the amount of CPU and memory and those kind of things. So Azure Container Apps is a fairly new service. It was released, actually I don't remember, maybe 1.5 years ago, GA. And it's called around serverless containers for microservices. So it's serverless in the sense that you don't need to pre-provision any infrastructure. You can just define your application and deploy it to the cloud, and container apps will run them for you. Now under the hood, this runs on Kubernetes, but you don't really need to learn Kubernetes, and that is actually a big thing here. And I worked with a lot of teams that want to go the Kubernetes way because they have seen it and they are impressed by everything you can do with Kubernetes. But there is a big starting learning curve is pretty steep in the beginning, and then you end up with, even if you deploy your application, you still have a cluster to maintain and upgrade and scale and so on. And it's a little bit of a new world for many, and they don't really need all that power. So I think this service is a really good fit for many of my customers' needs, and hopefully for you as well. So it's running Azure. It's built partly on open source, so they use a lot of open source components, and I'll come back to that. So generally, the idea is that focus on your applications and not on the infrastructure. So obviously you can pretty much build and run anything in the container apps. Just put it in a container and you can run it there. So, but there are some target scenarios that is really nice, and here are some of those. Obviously, microservices is the thing we're talking about, being able to deploy and scale multiple services. But also things like doing public API endpoints, web apps. It's a really good fit for web apps as well. Event-driven processing, if you have things that consumes, for example, messages from a service bus or something like that. Typically background workers. Those are really, really nice to run in a container app because you get help with the scaling and also the notifications. Also background processing. So pretty much anything you can run in here in a container app. And so we'll walk through some of the features that will hopefully make you see why this is a good fit. So just a question, how many here have actually used or played with container apps? So a few of you, maybe 10%, that's good. So let's talk quickly about the concepts around container apps. So first up, we have what's called an environment. So this is, you can think of this as maybe as your logical boundary for your application. So you need to create an environment which you will then deploy your container apps into that environment. So some things are defined on the environment level, things like logging, for example, and networking, those kind of things. And then you will deploy your application inside this environment. So when you deploy your application, you get what's called a replica, and this is actually terminology coming from Kubernetes. So some of those, terminology actually sips through the abstraction here. So if I now deploy version 1.0 of my application, it will run as a container as a one replica. But there is one more concept on top of this, which is called a revision, which is an important one. I will talk more about that later. So revision is pretty much like a snapshot of a particular version of your application. And if you know about containers, how you work with containers, you know that you never really modify a running container. If you want to deploy a new version, you actually deploy a new container and then you tear the old container down. And this is the same thing here, but it's called revisions here. So if I deploy version 1.0, I get the first revision, and I can now access and run my application. If I deploy another version here, 2.0, I will get a new revision. And the old revision will still be there, and we'll talk about how you can handle that old revision. Because sometimes you just want the old one to go away. Sometimes you want to have actually multiple revisions running at the same time for various reasons. So revisions is an important concept here. And then obviously you can deploy multiple container applications within the same environment. And by doing so, they can also communicate with each other inside here without going to the public network. In addition to this, we have a virtual network, and if you create one of these environments, you will by default get your a virtual network created for you that you don't really see or manage. But you can also obviously pre-provision your own custom VNet and deploy the container apps to that VNet. And obviously there's a lot of advantages by doing that. And finally, we have the log analytics workspace. This is where all the metrics and logs and everything will be routed, so both from your applications, but also from the container apps environments, also like things like the system logs and those kind of things. Everything will go down there to the log analytics workspace. And obviously, you can pre-provision that as well. So creating container apps is really easy. It's really low friction here. As long as you have a container image somewhere that you have built and published to a container registry, it's really easy now to deploy it. So you can, for example, do this using the Azure CLI, which is my favorite way. So there's two things. First, create the environment. And you can see here that you can specify things like the log workspace and the virtual network, if you have that. You can also skip that, and then these things will be provisioned for you, which is nice for demos and when you try things out. But for a more realistic scenario, you would typically pass it an existing VNet and the log analytics workspace. And the other part here is then to actually create the container app, basically by pointing it to a Docker image somewhere. In this case, it points to a public image, but obviously it can be your own image. And then you would also need to pass the authentication credentials in some way. And there's multiple things to do that. An alternative to use CLI is to use ARM or Bicep, which is nice when you do this from a pipeline, so you can run this over and over again. But you can do this both ways, and sometimes you will use a combination of this. In the demo that I will show you later, I'm using Bicep for deploying all of the resources. Then I'm using the CLI actually to do the revision swapping that we'll talk about. But since many of you haven't tried it, let's just quickly see what it takes to actually create one of these things. And hopefully, can you see back there? Silence, is that yes or no? Okay, I see at least one thumb up. So just shout if you can't see it. The screens aren't that big, but maybe you see better. Make it actually bigger, thank you. Great. Thank you. Okay, so I already have a few container apps environments. So I created one beforehand. So what I'm going to do now is to create a container app inside this environment. So if I go into this one called Container App Demo, I could within here create a new container app. So I could do this from the portal, but I can also do it from the CLI, like I showed you before. So I'm going to use the CLI here. So container AC container app create, and it's really dark here. So fortunately, I pre-written the command, so let's just run it. So what I'm doing now is I'm pointing to the existing container app environment called Container App Demo. Oh, this is also really small. Thank you. And I'm pointing to an image that I published to Docker Hub. So it's a public image per se, just something to deploy. And it's already created now, which means it's deployed into the cloud. And you get all the information about this container app back here. And we're not going to go through all of these lines, hopefully. But one of the most interesting parts is probably the URL that you get as an output. So let's copy this one and head over here just to see what we have. So there we go. This is file new application in Visual Studio, and I published it at the Docker image. But hopefully you can see how easy this is to actually deploy it now. It's really not more complicated than that. So it's really, really easy way to just deploy things into the cloud. So it doesn't have to be like this full microservice system. You can also deploy simple applications like this. And you do get a lot of benefits by doing so. So if we go back here now, we should see the container app here. And we can go inside to take a peek of some of the things that you can configure around a container app. So if we go to the containers, this is now where you see the information about. I can also zoom like this. So again, you can see which image I'm using, which version I'm using. We also have things like environment variables for configuration. We have health probes, which is, I'll come back to that later. Then we have scale and replicas. So this is where I could define how this application should scale and how many instances I should have. So now I haven't configured anything. So by default, it will actually say 0 to 10 here, if you can see this min max. And this is actually one important feature, I would say, around container apps, is that you have the possibility to scale down to 0 instances. And it will actually kind of wake up when you make a request to this particular container app. So this is important for many reasons, but mainly around resource cost, right? So you can actually scale down an application that's not being used, and then when something happens, it will wake up and you can scale up. So for many cases, this is perfect, especially for dev test scenarios, but also for some production scenarios for things that doesn't have to be running all the time. Maybe it's okay that it takes a short amount of time for it to wake up and process things when it comes. So it's a really important concept there of being able to scale down to zero. And then we have revisions. So this is an important concept, and I'm going to go back to the slides just for a short while to kind of explain that. So as I mentioned, you can think of revisions as a kind of immutable version snapshot of your container app. So typically a particular version of your container app. And when you deploy a container app, you can specify, do I only want to have one single revision active at any time, or do I want to have multiple revisions active? And this really depends on the type of application. In many scenarios, you only want to have one instance running. For example, one version running, I would say. So things like everything running in the background, the background processing, those kind of things is typically you'll only have one active version at any given time. But maybe for the public things, like the API and the web apps, maybe you do want to have multiple versions running at the same time. And the reason for that, I'll come back to that, is that you can do a lot of things by having multiple versions running at the same time. You can do things like blue-green deployment, you can do A/B testing, you can deploy a new version and test it before you actually roll it out into production. So those are some of the reasons why you want to do that. So for some changes, they kind of differ here about what type of change you make. So they call it revision scope change. That is when you actually create a new revision. But some changes doesn't require you to create a new revision. And it kind of makes sense that if you, for example, change the version of your image, you build a new version, then obviously you're going to create a new revision for that version. But let's say that you change some secret values that you read from your application. Then it doesn't make sense that you actually need to deploy the application because the secrets is stored separately. So depending on the type of change, some of those will require you to create a new revision, and some of them won't. And this is really related now to traffic coming into your application, as I mentioned. So the reason for having multiple active revisions like this is to be able to actually send traffic to it. So this is called ingress. This is also a concept from Kubernetes, but this is about how you want traffic to reach your container. For some things, you won't have an ingress, or actually you will have an internal ingress because you don't want to have public traffic to that particular application. So again, the background processing jobs, maybe internal APIs. You never want to have traffic being sent to those things from the outside. But for your public-facing APIs and web applications, you want to have a public ingress here. And it supports HTTPS and TCP and so on for the ingress, and you can do things like TLS termination. But also then you can do what's called referred to as traffic splitting. So again, if you do have multiple versions running of your container apps, you can now use this feature to actually route traffic to the different versions. So a very common scenario would be that I'm building a new version, but I want to verify that that version actually works before it hits production. So one way of doing that is to deploy it as separate from the existing one, and then you can start routing traffic to it. And you can do this in multiple ways. One way would do it like this, to actually just send maybe 10 or 20% of the traffic to the new one. So you can kind of gradually roll out the new version. If everything looks good, you can increase that one until you hit 100%, and then you will remove the old one. That is one way of doing it. If you do A/B testing, you probably want to have both ones running all the time and just send traffic to it, maybe 50-50. So a lot of options here, a lot of flexibility around this feature. And you define this either like this using bicep. You specify the revisions, how much traffic should be sent to each of these revisions. Or you can also do it using the CLI like this. So basically I'm saying send 80% of the traffic to that revision, send 20% of the traffic to that revision. And I'll show you later where I'm doing this in a deployment pipeline, where you can kind of verify the functionality before sending all the traffic to the new version. So let's see how this actually works. And so in this case, let's see if I can go to back to the overview for the container app. And we can just click this one. So we have the application running here. So let's deploy a new version of the application. So I'm going to do that. So if we go to the revision, we can see that we now have one revision running, which makes sense. We only deploy this once. But from here, and this is obviously not how you would do it in a real-life scenario, but you can create a new revision from here. So basically, what I want to do now is I want to upgrade to the next version. So in this case, we deployed 1.0, right? But I want to now deploy 2.0. So I'm just going to create a new revision based on the old one and just change the tag here, the tag version. So I'm just going to save it and click create. So now it says deploy revision. So now under the hood, basically what it does now is that it creates a new container, downloads the image version, and it's going to start up the new one. And in this case, it's going to now eventually shut down the old one. So now you can see that we actually have two revisions here. And if I zoom in a bit, you can see it's still provisioning. So the UI isn't always up to date here, but you can see now that it's you have the traffic to the right here. So what this means now is that when this is done, all the traffic will go to the new one, and the old one will be deactivated. So if you go back to this one, the only change I made to the application was that I changed the background color. So now we kind of see that now it's running 2.0. And again, now we only have that the one revision. So this is the default behavior when you create a container app, that you have one revision active at a time. You deploy a new version. Container apps will make sure that the new version gets the traffic once the container is up and running and ready to accept requests, and then it's going to remove the old one. And that's how you achieve zero downtime when you do deployments. So this is the default behavior, but if you can see, we have this thing called revision mode up here that we can change. And now it says single here, because that's the default. And again, that means that we only have one single active revision at a given time. But let's change this. And I'm going to switch to multiple. And it says several revisions active simultaneously. So I'm going to change the configuration now. And now I'm going to deploy a new version, and you'll see that the behavior now changed compared to how it used to work. So again, now we have still one active revision. Now we can actually also, since I changed to multiple now, we can also actually show inactive revisions. And then we can actually see now the old revision, which is the 1.0. It's still there, but it's stopped. It doesn't cost me anything. And eventually it will be purged by container apps, but it's still going to be there. But let's create another revision then. So let's deploy the fantastic 3.0 of this application, which will give us yet another background color. So let's deploy this. And just compare now to what happened before when we did this single revision mode. So what we should end up with now is that we're going to have another revision, which is the top one there. But it's not going to get any traffic. So all the traffic is still being sent to the old revision. And this is the default behavior. So now we can see that we have two active revisions, but one of them doesn't receive any traffic. But if I want to now, all of these revisions now is still reachable. So if I click on this revision that doesn't get any traffic, I can actually get the URL. And if we switch to this one, we should see yet another color. So now I actually deployed the new version, 3.0. I can access it like this, but none of the customers sees it because they don't go to that URL, right? they go to the public one. So again, let's go just back here and click on the public one. So here we'll still see the 2.0 version. But obviously, I can use this now to run smoke tests, have people testing it. If everything looks good, then we can swap it into production. And then we can do that by changing the traffic. So now it says 0% to the new one and 100 to the old one. So I could swap this around, and then I will just pop the new version into production. I could also do, as I mentioned, maybe do some kind of A/B testing. So actually say 50% traffic to each of these revision. So if I just change this, and there we have the save. What should happen now, once this is done, is that 50% of the requests will go to the new one, and 50% of the requests will go to the old one. So if I refresh this, you can see that on average it's going to be every other request is going to go to the new one. So again, this is ways to do A/B testing, a way to do gradual rollouts without having any downtime. So a very controlled way of doing this. So a really nice feature. And this is really, if you have worked with Kubernetes, this is completely built on top of that, but it's just a lot simpler. You don't have to learn a lot of things to do this, which is really nice. How many have worked with Kubernetes, by the way? Oh, almost more than container apps. So maybe you will be switching around after this session. So let's talk a little bit about scaling. We saw how we can deploy versions in a controlled way. So scaling is obviously a very important part, and both scaling up to meet increased load, but again also to scale down and to actually being able to scale down to 0. And this is one of the examples of the open source components that is part of container apps. So it's called Kada. And it's been around for several years, and this is how you would typically do this in Kubernetes. You would install this and configure it yourself. And it enables you to do event-driven scaling. So you can scale on a lot of different things. For example, the number of messages on a queue. And there's all sorts of things. And again, this is now based on the open source project. So any additions there will actually eventually trickle into container apps, which is really nice. So here are some of the examples that you can do. So you can scale based on the number of HTTP requests. So say that if the number of concurrent requests is above a certain threshold, then I want you to scale up, and you can specify how much you want to scale up. You can use the event-driven scaling. And you have all these various sources. So it could be Azure Service Bus, but it could also be things like MySQL. It could be Redis and so on. So any kind of events is available as these Kada scalers that you can just plug into. You can also do things like scale, based on CPU and memory, and it really depends on what type of application you have. So what's interesting is that these two ones on the left here is they can be scaled down to 0 instances. While if you want to scale on CPU or memory, you can't scale down to 0 because then there is nothing to measure your CPU on. So it kind of makes sense. So what's cool about this is that again you can scale this down to 0. So for example, if you want to do HTTP scaling on your API, you can scale it down to 0, which means that you don't pay a single dime for it. But as soon as the first request comes in, then this scale rule will kick in and scale up your application. It will start accepting requests. So that's actually really, really powerful and can make for really resource-effective usage for your applications, instead of having things running all the time and then just once in a while process some kind of request. So the other part, we talked about container apps now, which is how you will host your system and run it. Then I will talk a little bit about Dapr. So Dapr is a framework. It stands for Distributed Application Runtime. And this is more for for the developer-centric, for actually building your microservice applications. Because if you have been down that route by again splitting apart your application into multiple independent services, you're gonna find out that there is a lot of things that you need to do. you need to solve. A lot of things becomes harder, and there's a lot of like boilerplate things you need to run. And depending on the number of services and depending on the tech stacks and so on, this can be actually a lot of work. So Dapr is another open source project. It's part of the Cloud Native Foundation, which kind of tries to solve this by abstracting away a lot of things and make it a lot easier for you to build microservices, and again focus on writing your application instead of doing all this plumbing, implementing things like service discovery or pub sub messaging, various state management, and so on. And so what it does is that it kind of abstracts away all of those complexities, and obviously with that abstraction, comes some trade-offs. So you can't do everything with Dapr, but you can do a lot of things. So I think you can probably apply like this, 80-20 rule or 90-10 rule when you should use Dapr or not, and you can use it for both. And this is not like a requirement if you do container apps, but this can help you actually build those microservices. So they try to kind of implement best practices around how you would implement microservices into different building blocks that you can use. And they will handle things like resiliency. So, for example, doing retries, doing exponential backoffs, things like circuit breakers, handling timeouts. Those kind of things is something that you need to handle if you start breaking things apart. Message guarantee, for example, if you building a message-based applications, so making sure that your messages comes to the receiver endpoint once and only once. Secure connections and a lot of other things. And so here are some examples of the various building blocks that is part of Dapr. So they have things like state management, which is then basically an abstraction if you want to store data in some kind of state. And behind that could be really any number of existing storage mechanisms. So it could be like a Cosmos DB, it could be Redis, typically some kind of key value or NoSQL store. And then you just get a very simple API instead, so you don't have to write any code really to, for example, store data or retrieve data or do queries. Also service invocation, a big thing when you do microservices. You have to have a way to, as I said, know where are the other services running, how can I access it, how can I call it. And Dapr works fine both running on your local machine and running in the cloud, and it will solve this problem for you. You don't have to know where services are running. That's actually a really nice experience. Also things like secret management. You need to have a way of storing and accessing your secrets. So again, when you implement this, you can say that I want to use Azure Key Vault, for example, but that's not something you need to implement yourself. That is handled by the building block for Dapr. And I will show you an example in a few minutes. There's actually a few more building blocks than what I'm showing here. So again, this is an open source project, and functionality is being added all the time, which is obviously a benefit for us. So how this actually works is that Dapr is implemented by using what's called a sidecar, which is a kind of a design pattern. And this means that if you have an application consisting of two services, A and B, and they want to talk to each other, they won't actually talk directly to each other. Instead, it will go through this Dapr sidecar. So every time you use Dapr and you run your application, every service will have a sidecar running next to it, which will actually implement all the functionality. So this is what makes possible, for example, to do service discovery. So I only need to say, I want to call service B, and then I let Dapr handle that complexity for me to actually figure out, okay, where is service B actually running? How many instances? Where should I route this request? But also do things like secure communication, so you can do encryption all the way, handling things like resiliency, right? Doing retries if it fails, doing circuit breakers if you have a lot of load, those kind of things. Also, you get tracing and log and metrics and so on. And I'll show you an example of how this looks in code. So in addition to this is the service invocation. In addition to that, we have then the different building blocks, so things like state stores. And these blocks are optional. You don't have to use them. But again, if you're storing data in, for example, Cosmos, or Redis, Cassandra, there's lots of more choices here. You can actually just plug that in, and you don't have to write any code. You can actually switch it. You can run, for example, your local Redis if you run it locally, you can do Redis. If you deploy it to your production, you can do Cosmos, for example, without actually changing a single line of code. So state store is one of the building blocks. Publish, subscribe for doing pub/sub messaging. Again, you can select the various types of stores for this. We also have resource bindings, which is a way to actually communicate with external systems. Also having things happening on the outside trigger things in your applications. For example, an event on a message queue could be an example here. And how you do this is that you specify this in a component file, which is a YAML file. This is where you actually specify, I want to use this building block and I want to use this type of store. So as an example, for a simple one could be if you want to do pub/sub messaging, and you can then select, I actually want to use the Azure Service Bus as the implementation. Then you define this component file, and you give it a type. So in this case, this is what actually how Dapr knows which of the implementation of this building block that it should use. So in this case, I'm pointing it to Azure Service Bus. And then depending on what type I'm using here, it is going to need some metadata. In this case, the connection string to the service bus and so on. And then that's really all that you need to do. And then you can use the APIs and the SDKs to call it. And it doesn't really matter if it's the Azure Service Bus or if it's Redis or if it's N Service Bus. You will have the same code. So I'm going to show you a demo, just a sample application that I have, which consists of 3 parts. So there's a web app, an API, and then there's a background job that processes orders. So the web calls the API. The API uses pub/sub to notify the processing that there is a new order. So that's going to go through Azure Service Bus, and the data will then be stored in Cosmos DB. So I'm going to show you this locally, and then we're going to see how it looks when running this in the cloud. So let's head over to VS Code. And all of this code is available, by the way, on my GitHub account. I have a link in the end of the presentation. So again, I have the 3 applications is hiding here, the API and the processor and the order web. That's the 3 applications, and we have some other things. And let's just take a quick look of how code actually can be, how you code with Dapr. So for example, when I use the order web, I'm going to make a call to the API. And zoom up. So it's really 2 lines of code here, where the first line is just instantiating the Dapr client. And again, Dapr is portable. Everything is API based. So you can do everything by calling the APIs of Dapr, which means that it's not in any way bound to a particular platform or language and so on. But then for the most languages, there is SDKs, which makes it even more simple. So you don't have to figure out the APIs yourself. So in this case, I'm instantiating my Dapr client, and then say I want to call the method order on the service called order API. And this is really like the magic here. So the order API here, that's actually the identification or the ID of that service. I don't need to specify where that service is running. If it's running on my machine or if it's which port it is running, I just say call order API and you figure out where it's running. And this will work when I run it locally, and it will work exactly the same way when I run it, for example, in container apps, which is quite powerful. And another example, if we go to the processor, here we can see another example where when you get a message through the pub/sub, I'm calling the save state async, and I'm giving it, here is the definition of the order, but again, I'm referring to the name here, state store. So again, where is that coming from? State store, this is just a string. So this is where the component file comes in. And they are specified here. So I have a few YAML files here. So I have one for pub/sub, one for the state store, and a few more. And so let's just take a look at the state Cosmos then. So here, this is actually now where you can see the state store. This is just the name of that component. And then it specifies, okay, what type of store do you actually want to use and how can I access it. So the type here is now state.azure.cosmos.db, and then I will pass it some information so it knows how to actually connect to a Cosmos DB. But again, I could, for example, I have commented this out, but I could, for example, just as well use a local Redis instance running in a container, which is typically what I would do if I run this locally. Then I would just use this component file instead, and the code will look exactly the same. Which is, some of the power here is you can switch it depending on which environment it is, but also there's a lot of code, a lot of plumbing code that you don't have to write, which is actually quite nice. And just a final example, now we saw how we can invoke things, how we can store things. If we look at the API, it will also use the pub sub. So in this case, we have the publish event, specifying again, okay, I want to send a message to using the order pub sub component. And again, that is now specified in a component file here with the same name. And here I'm pointing it to an Azure Service Bus. Again, I could use Redis here. This is just for example. So I'm going to run this now. And so the thing with Dapr is that if I run the application, I have to make sure that the Dapr sidecar is running next to it. Otherwise, nothing of this will work. So this is the application, the web app. And we can create some order, blah, blah, blah. And it will eventually show up here once it goes through the background one. So everything is now running on my local machine. But again, for this to work, I have to make sure that those sidecars is actually running. So Dapr needs to be running next to my application. And you can do this in many ways, but if you're using VS Code, this is actually quite simple. So there is an extension to VS Code that will help you with a lot of things around Dapr. You get some UI and dashboards and so on, but maybe more importantly, you also get some tasks that will help you with this. So if you are using VS Code, you probably know that you define this launch configuration, this how you specify how you run application. And this one looks pretty much exactly like you would do with any .NET application, how you start it, except for one thing, which is this pre-launch task here. So this is a task, and tasks are defined in your task file. And let's take a look at one of those. So this is where the magic sauce is being cooked. So this is now a task that comes with that extension, and this is now what actually will kick off that Dapr sidecar for me. And here I can specify the ports and all sorts of things. But that means that when I run it in VS Code, it will automatically spin up the Dapr sidecars next to it, and it will just work. And again, this is really nice now because when I run this locally, I don't have to figure out which ports or anything these things are running on. It will just find it, and when I deploy it, I don't have to change anything. Even if I do it on container apps and scale out, the code stays exactly the same. So it really makes a lot of things simpler when you do this. So actually, let's see if we see here, if we go to the debug console here, we can see that I have these 3 applications running, which makes sense. That's the web and the API and the order processor. But I can also actually see the Dapr sidecars here. So if I go to the terminal, I can see those Dapr sidecars running, and this is actually where I see the log coming from the sidecar. So any errors or the logging is visible here. And we actually might be able to see, let's see if I can find this here for the web. It's kind of hard to see in log, but what you typically see here is that when I start up these things, the web and the API, I start them up at the same time, and then the web will make a call to the API immediately. But typically the API isn't ready yet because it's starting up. So if I would run this, you've probably seen it yourself, then the first request will fail. And then I could refresh it, and then it works. But in this case, this always works, because by using Dapr, when the web calls the API, it will fail initially, because it's not ready to respond. Then it will automatically do a retry. And I can configure that exactly how I want that to work. And that's a separate component file, which is called here the resiliency file. So in this case, there are some default settings here, but in this case I can specify, for example, I want to make sure that I want to retry up to 5 times. So I can just create a resiliency specification, and I want you to wait 5 seconds between each of these tries. And down here, I'm specifying here that this is for the order web. And if I call the order API, I want you to use this resiliency, the policy. So there's lots of flexibility around this. And again, this is things that can be quite tricky to get right. And it handles more things than just retries. So again, it supports, for example, circuit breakers, which is a concept that is good to know. It also handles timeouts, and you can configure this on either for all applications, or you can have different policies for different services, which can make a lot of sense. You probably don't want to have the same behavior for all the parts of your system. All right. Okay, so that was Dapr. We talked about container apps, how to run the applications. Dapr is how to kind of develop the applications. And there's multiple options of hosting Dapr applications. As you can see, I could run this locally just fine. Obviously, I can run this in Kubernetes. I can also run it on any virtual machine. But I can also run it in container apps, and container apps kind of natively supports Dapr. So you don't have to install Dapr or deploy anything specifically. Instead, you can just say, I want to use Dapr. So here's an example how you would do this using Bicep. So there's a few settings that specify that I want to use Dapr, and then you give it the information about the ID, so it can do service invocations. So it's really the same information that I showed you in those the task file that I showed you. This is now specified here. That's the only thing I need to do, right, to actually use Dapr in my target environment. And again, what happens now if I have two apps that talk to each other? It's going to make a call using the same code that I just showed you, and it's going to go through the Dapr sidecar, which is now being spun up automatically by container apps. And in case you have any external things, it will work exactly the same way as when I did it locally. And again, I don't need to change anything. And if I want to now, I could again use different components locally compared to when I run it in the cloud. So maybe I don't want to actually go towards Cosmos DB when I run it locally. Maybe I want to use a local store. Then that works fine. Again, without really changing any of the code. So let's put these things together and see a more full example here of how you would run the same application that I showed you, but in Azure Container Apps and using Dapr to do this. And in addition to running the same application, let's see how, using Dapr, we're going to see how we can do scaling using the KDA. So in this case, I'm going to scale it based on the number of messages on the service bus. So I'm going to try to send a lot of messages to the service bus, and when that number of messages starts to increase, I want this order processing component to scale out, so it can process more messages, which can be a really nice way of doing this. So maybe you have 1 or even 0 instances running, but as soon as something happens on the queue, then you can scale up and process them fast, and then you can scale them down again. Again, really to save resources, to save money in the end. You don't need to have them running all the time. And I'll show you a deployment pipeline, how you can kind of orchestrate this using, in this case, GitHub Actions. So let's go back to the portal, and we can go to another container app environment that I have. So I have already deployed this, and I will show you how. So here we have the 3 components, the same application that you just saw, but now Now they are running as container apps instead of locally on my machine. So the web and the API and the processor. And let's dive into the web application. And again, we can click over here to go to the URL. And you see the same application. And it talks to the API, it talks to the processor. I should be able to create things here as well. Test 2, blah, blah, blah. And it should pop up here. And so actually, if you saw the URLs, maybe you thought that was a nice URL. And it's not really, but this is how, by default, the URLs to your application will look like. So it will end with the region.azurecontainerapps.io. Before that, you have the first part is the name of your container app or the web, and the middle part, with a weird name, that's actually something that's generated for your environment. So when I create an environment, I will get some kind of unique name here. Obviously, this is not what you would use, in production. Then you would use some custom DNS on top of this or custom domain. But again, you get this publicly facing URLs if you decide to show it like that. So let's go back here, and so I deployed this already, and let me show you how I deployed it. So I didn't go, click in the portal like I did before. I defined this using Bicep, which is then one of the options. And let's take a quick peek at that. And again, all of this is available if you want to have a closer look afterwards. And so here I have various Bicep files where I specify the environment and then my 3 different applications, container apps, and some additional role assignments. And if I click on the main one, which is my starting point, it's always nice to visualize it like this. Oops. Let's put it down here. Let's zoom a little bit. So again, I'm defining the environment, specifying, for example, application insights. We have the log analytics workspace. And then you can also see actually that down here we can see the Dapr. So Dapr is also specified as the components within this. So it's all part of the same resource definition. And up here then we have the 3 different applications, each with its own identity as well. And if we dive in, for example, to Order Web, the web application, you can see how it looks. And so just to point out a few things, you can assign an identity to it, which is typically what you want to do. In this case, a user-assigned identity. It makes it possible, for example, for it to communicate with other services, to pull images from a container registry. Then we have the thing around revision mode that I talked about before. So I'm saying here that I want to have these multiple revisions for my web application, so I can do this blue-green deployments. I specify that I want to have an ingress, which is external true, which means that I can access it from the outside. If I set external to false, I wouldn't be able to access it from the outside, which is what I'm doing on the other parts of this application. But then we have Dapr here. So this is now where I specify that I want to use Dapr. I want to have it enabled. I specify a port, and then the ID again. So this is the ID. That's what I need to know if I want to call this application within my environment. So you saw before when I called the order API, that's really the string that makes this possible. Then I don't need to know where it is. Dapr will figure it out for me. So that's the Bicep part, and for deploying it, I have a GitHub action, and I did a minor change again. I think I changed the background color, and I triggered a pipeline for this. So you can see down here that it's has built, and I deployed this to a staging slot. So if I've been using app services, they have this concept of deployment slots, which is really similar to what I'm doing here with revision, being able to deploy it to one revision, test it out, and then swap it into production. That's really what I'm doing here, but from a pipeline. So if you go back here to order web and look at the revisions, we should see, and here I actually have a lot of revisions. And if you look at the top one here, you can see that the number 2 here is the one that is getting traffic. That's like my current production version. But then I have deployed a new version from that pipeline. So that's now my staging slot. But again, you can see that it doesn't automatically get any traffic, but I can still call this, and I do that from the pipeline. So in the pipeline, I deploy it a new revision. Then I can run some tests against that URL to make sure that it works. If everything looks good, then I can go back to the pipeline and approve it. And then what will happen is that now it's actually going to swap that traffic. So just to show you how that actually works, let's check inside this GitHub action. And we don't have to dive into the details of the GitHub action itself. But if we go down here a bit, let's just focus on the important things here around container apps. So you can actually see now that I'm using the CLI here. So you need to kind of figure out yourself about these revision things. You need to kind of see, okay, this is the revision I want to kind of promote, or how I want to send traffic to them. So I'm using the CLI within the pipeline to kind of figure out, okay, what is the current revision, the current version. So I'm using the CLI to actually get that. And then I can create a new revision. So I'm using the revision copy command, which will then create a new revision. Exactly the same thing that I did in the portal, right? I did create new revision. I specified a new image version. That's exactly what I'm doing here. I'm doing revision copy, and I'm specifying the new image version. But then in the next line here, I'm in number 2 here. I want to make sure that the new revision doesn't get any traffic, so I point all the traffic again to the current revision. So again, I don't want to leak the new version into production before I have the chance to test it. So if we go down now to see what's happening now when I'm running it, it's down here. Again, I'm using the same command here to kind of get, okay, which one is the slot that is running, and then I'm using the same command, but now I'm giving 100% traffic to that one. And so if that is completed, let's go back to the pipeline here, see if it's done. It's done, so it's swapped into production. So we should now, if we go back here and refresh this, we should see now that the new version is now actually getting 100% traffic. So that's how you would kind of implement this in a pipeline to kind of do this in a controlled way. All right, so actually I only have 2 minutes left, so that's a little bit short of time. So I won't be able to actually show you the scaling. So I'm just going to quickly show you how the scale rule is set up. But I won't do the actual load test and so on. So if you go to the container apps, if you remember from the scenario, what I wanted to do is to make sure that if we get a lot of messages on my service bus, I want the order processor to scale out so it can actually process those messages faster. So if you go to this one and go down to scale, we can now see that we have actually one scale rule defined here called queue-based auto-scaling. Again, it says 0 to 10, so by default it's going to have 0 instances running. If we go into this one, we have some settings here, and this is specified in the bicep file as well. But basically what I'm saying here is that I want to check on the topic. This is the Azure Service Bus. So the topic called order created and the queue length 1. So in this case, it means that if I get more than one message, I want you to scale out to a maximum of 10 instances. So 1 is typically quite low, but typically when I demo this, it just makes it easier to demo. But typically you can have the threshold a bit higher. But again, if I would now start to sending a lot of messages, it would scale up from 0 instances. So the first one would take a little bit of time, the first one from 0 to 1, and then it will scale up quite quickly to 10 instances. And then it will stay like that for roughly 5 minutes. So I can actually just quickly show you. I ran this before, earlier today, just to show you what it looks like in the metrics. Or didn't I run it today? Oh, sorry, that was the wrong metric. We have the replica count here. So, just to prove that it actually worked, I ran it before. And you can see here that when I ran it, it quite quickly went from 0 instances up to 10. And then processed all the messages. And when there were no messages, it stays for, by default, I think it's 5 minutes. Because you don't want it to flip up and back and forth too much. So you want to have a fairly stable processing here. And then after 5 minutes, if nothing more comes in, it's going to scale down to 0 again. So just to end on the most interesting thing, which obviously is pricing. What does this thing cost? And from the beginning, we have had this consumption plan, which means that just pay for what you're actually using. So what you're paying for is partly the number of requests coming in, and then you pay for the amount of CPU and memory that you're using. So when you define the container app, you can specify how much of the virtual CPU and memory they will assign to it. And if you run that for 10 seconds, you can multiply this number by 10 seconds, and that's what you're going to pay, plus eventually the number of requests. So you can do a lot of things to actually save a lot of money here, in particular the dev test environment, to scale them down when you're not using them. And if you compare this to like running Kubernetes cluster, this can actually be a lot cheaper, to be honest. And then quite recently, they have also, it's still in preview, but they have now a dedicated plan, which is maybe more traditional, but this will allow you to have a more isolated environment. And this is more of saying, I want to provision these types of machines with a certain size, and then you pay for that instead. But it gives you a lot higher isolation compared to the consumption plan. So a lot of companies will want to use that plan instead. But it's still in preview, but can be worth to know. And I also know that the Build conference is running right now, so I was actually a bit nervous because when they release stuff, things break. But it has been working pretty well. But there was a lot of announcements around the container apps. So check out the news from Build. Lots of interesting stuff. It's not just AI. It's also things around container apps. But they're going to put AI here soon anyway, right? The container app copilot is going to come soon. I'm sure of it. Okay, I'm out of time, so I don't want to hold you any longer. So thanks a lot for coming. I hope it was worthwhile. And I'll stick around here for a while if you want to have questions. And I'll be around also tomorrow if you have any other questions. Just hit me up. Thanks.